Hello friends, Shivansh this side, and today we are going to discuss this indefinite integral, and I believe this is one of the most difficult indefinite integral problem I've ever faced, and it took me a lot of time to solve this problem. And I think the way I solved this question wouldn't be the most elegant way or the shortest way, but it was the way by which I did it. So have a look and please watch the video till end. And in the comment section, it would be I will be very grateful it for if you tell a good solution for it, because my method is very longer, but it's interesting and surprising that how a question can be so long, and that too of indefinite integral. So to start, it was again a mere intuition, because if I replace x by 1 by x, because in polynomial functions when a polynomial is in denominator, not polynomial, basically rational function, if it is in denominator, not even rational I guess, then it is nice and it is elegant to see that what will happen if we replace x by 1 by x. So I started with that, and no, I'm not solving the question for first time, but I solved it by myself. So I replace x by 1 by t, then dx will become minus 1 by t square dt. So minus for that thing, okay, x to 1 by t dx to minus dt by t square integral dt minus by t square, it is 1 plus t4 by t4, and from here I will get t cube out. 1 plus t4, if I replace x by 1 by t by t out from, like, t square out from this root, and 1 by t square t out from that. I believe this is correct, or let me check it once again. What I'm saying and my claim is 1 plus 1 by x raised to the power 4's root minus 1 by x square, x4 plus 1 by whole root by x square minus 1 by x square. Yeah, and pull out x out, and I don't know why I'm pretty surprised, because the first time I solved the question it wasn't the case. Maybe that time I would have done something wrong, but anyways, I let me try by the same way, and I think I will get the answer. If I will not get, of course I will not upload the video, and if you're watching this video, that means I've got the answer. So I mean x to 1 by x minus 1 over here, and t out of whole root t5, and t cube goes out, and this little t cube over here by root 1 plus t4 root of 1 plus t4 minus 1, but I'm still pretty doubtful by this one, but no problem. Okay, so let me put now. It's a very obvious step, minus, of course, that I do this thing and put 1 by t power 4 as k. Actually, in integration I have a major problem, that I not like solving answer, like I not finding answer till the final point. Way I reduce it to a known integral, I'll leave the question. a bad habit, but I don't know why I do it. dk by, okay, हाँ, k root of root k minus 1, then root k plus 1, like rationalizing it. I would like to multiply. I don't think now the problem would be solvable by the way I did it in the first way. In the first time I did problem over there, and I'm still thinking. Oh, it seems to be right. Okay, let me try. First of all, I will rationalize it with root k plus 1, k minus 1 in denominator, root k plus 1 in numerator. Okay, if you're watching this video till end, like if video is in front of you, that means this step is correct, because if it would not, it wouldn't have been correct. I wouldn't have been posting this video. 1 by k root of k plus 1 by k minus 1, and I believe in rationalizing it again by k plus 1. Yes, let's multiply k plus 1 in numerator denominator again. I will get this k plus 1 little over here. In denominator I will get k square minus 1. See, I'm telling you, I will not find the final answer. It's up to you. If you're interested in finding, I will just tell you the method, because I believe this is a right way of doing. Okay, now this integral is, yeah, it is. I got in a more simpler way. Now you just don't have to do anything. Split it about plus 1, you will get two known integrals. Okay, let me raise the question, because I want a list of all substitutions, so that if I want, I can get the final answer. Minus 1 by 4, very much out. I'm splitting it about plus positive sign. Yeah, I like making in this way. Now it is integral of 1 by root of k square minus 1 and plus 1 by k root of k square minus 1, and I believe this integral is of, okay, sorry, this integral is of sine inverse k, and this integral is a standard integral which reduces to ln k minus root k square minus 1. Like children who are studying in India, in our NCRT books, like the state board books, not the state board, basically the national board books, we are taught this as a formula. So we have learned it as a, oh sorry, k plus, I'm sorry, we have learned it as a formula, but to derive it, just put k as sec theta and you will get it, and stay till the end. I will show you derivation of this as well as this integral. I swear it. And this is it. Now let me put what k was. Okay, I can erase this step. Now only the thing which is useful to me is substitutions. So first ln 1 plus t4, and then k square minus 1 root ln 1 plus t4 plus t square plus sine inverse 1 plus 1 plus t4, and then x to 1 by t ln 1 plus t square plus t, sorry, 1 plus x square plus x4 minus 4 ln x. I hope you understand how I got this. plus sine inverse x4 by 1 plus x4. I believe this is the final answer. I haven't checked it, but I think this is the way. And yes, you have watched the video till end. I'm glad to find you till here. That means thing is correct. So as I promised a gift you are till here, I will show you these two integrals. Oh, in the answer I forgot minus 1 by 4. I'm sorry. Anyway, this video is not for one who is in online exam, finding answer by YouTube. Anyway, put case sec theta. Derivative of sec theta is sec theta tan theta. Of course, TK. Sec theta tan theta d theta. Put it over there. Sec theta tan theta d theta. Denominator I get tan theta cancel. Integral sec theta d theta. Integral of sec theta again. We are taught in India. We are asked in India to learn it as sec theta plus tan theta. But let me show you derivation of this as well. As a gift, you are still till here. Multiply by sec theta plus tan theta in denominator and numerator, and then you open it, you get sec square theta. You open it, you get sec theta tan theta. Its derivatives over here, it's form of f dash by f. Again in India, we are asked to learn this as a standard integral of ln f, but I will still show you the derivation. Put f as t, f dash dx is dt. Simple integral ln. So I hope you understand how we got this as ln sec plus ln sec plus tan. So we got ln of sec theta plus tan theta. We know ln we know sec theta is k. We know tan theta is root of k square minus 1. So this is it. And for the other one, integral dk by k root of k square minus 1. You may just simply see that if I take derivative of sine inverse, sorry, oh shit, my bad. I wanted to write sec inverse, I'm so sorry. Then I wrote sine inverse, it's actually derivative of sec inverse. So haste makes waste. Anyways, so I know the way of doing it, but let's start. I was just thinking that if I take something like k square common, I will get k square over here, then 1 minus 1 by k square. So I wanted k cube here, but okay, no problem. So let's start. Case again, k sec theta integral 1 by k sec theta cos theta by sec theta tan theta. Okay, I didn't want it to show it. Sec theta tan theta d theta integral 1 by sec theta over here. Okay, let me write it. Tan theta d theta root of k square minus 1 sec theta tan theta cancel. Integral d theta is theta is sec inverse. Okay, so this is it for this one. So anyways, actually the way I did the first earlier problem, in the first step, while putting x to 1 by x, I did a blunderous mistake and I got an integral which was like hell. But I would really like to share that integral as well, because solving that one was really very much harder than solving the thing in right. Actually, same thing happened when I was with my mathematics teacher in school. So I was solving a problem of physics, I believe, and it I got integral like this. Okay, I don't remember it specifically. It was 3 by 4 into x is 2. I think I got, yeah, it was t 3 by 2 minus 1 like this. And actually what I was doing a mistake, it wasn't like, it was a kind of physics question in which a ray of light was going like this and you have to find its trajectory. So yeah, we had to integrate, but I was doing a blunderous mistake while solving the differential equation, which was corrected by a friend of mine in school itself. But still, this integral became blunderous. But of course, I was able to solve, and I found this integral very nice because actually I remembered that what I put as substitutions. That's why I'm sure that sec 3 by 4 x is equals to 3 by 2. So put this because I don't know why I find this integral very interesting. D theta sec of course dt, so sec 4 theta tan theta d theta by, put anything, not like, I mean sec square theta minus 1 tan theta, that's gone. This is t, this was dt, it was t square by 2, so sec 4 by 3 theta square by 2 sec 8 by 3 by 2. Anyways, yeah, I was showing you that blunderous integral which I accidentally made. It was something the same, like I did almost everything correct. Just in the first step, I put x square over here. That's why I was confused while I was doing the question, that no x square here. Question is very much simpler way I solved it. I have to first post 1 plus x4t dt over here. No, not no root here, sorry. T over here, root of t minus root of t minus 1. This by t over there, root. Now I rationalized it. Actually, this integral will teach you something more better than the actual integral. By I'll rationalize my root t plus root t minus 1 whole root, and 1 is 1 dt. Now what I'm doing, I'm putting root t as m after drawing a root t inside. I mean, I split it in root t and I take a root t inside. This gets cancelled. Again, I'm doing some blunder, I guess. Anyways, I think I'm not. This is it. Taylor and root. So now I put m square is equals to t. Now m is equals to root t, dm is equals to 1 by 2 root t dt. Let me ignore constants. Let me put k over there because I'm concerned in inner part. 1 by root t, dt by root t is dm. So what I'm doing, root t is m. Root t is m. So root of t minus 1 is putting over square. You are understanding what I'm trying to say, I believe. By root m m plus root of m square minus 1. I don't know why I'm thinking I'm still doing blunder. Am I? I don't think, or I think is thing I did is correct. Oh, ah, I remember I got something like root t minus 1 by t. I put t as m square m. Yeah, it's correct. So the next step, which was the major step of the wrong question, is this. I'm putting it as another variable, let's say z, and very interesting thing is its derivative is something like m plus root of chain rule, of course. and then derivative of it 1, of course with respect to m, derivative of it 2 root m square minus 1, and again 2m over here, 2 gets cancel, m यहाँ रह जाएगा, this gets cancel, and it's m dm, like root of m plus m square minus 1. You made, okay, let me show you the whole derivative. This is not a good way to be on YouTube. Derivative 1 plus 2m root of m square minus 1, 2 here, 2 gets cancelled, this gets plused, this gets plused. Oh, what happened? Nothing. Root m square minus 1, actually I wrote m, so same thing into root m square minus 1 into dm, z root m square minus 1 into dm. Why I make so much chaos? Like the way I was solving that, again I made errors. dm is z, z, this thing is z, z dm is dz. So finally if I try to modify it over here, dz itself by again root of m square minus 1, and again I think I will not be able to solve, like now it's the first time because again I made the blunder. And what is m? For m I have to use this equation, z square is m plus, you might be thinking I'm killing your time. No, but it's a very nice investment. Z square minus m's whole square is equals to m square plus 1, sorry, minus 1, z4 minus 2 z square m's z square m plus m square, m square gets cancelled, minus 1 plus 1. Okay, what I needed was m. z4 plus 1 by 2 z square is m. z4 plus 1 by 2 root of z4 plus 1 by 2z square, then its whole square minus 1. Okay, now I'm giving up. No, I will not be able to solve it. Of course, it's a wrong integral. So sorry for me to waste your next 8 minutes. Sorry, previous 8 minutes. Anyways, I hope you would have learned, because anyways, derivative of root of m plus root of m square minus 1 is still very interesting. So this question was for just an integral, and I solved 3 to 4 integrals, like 5 integrals. No, 6, even sec theta 1 integrals in this in this video. So I hope you like the video in which I've solved literally 6 integrals made from a mistake or an all. Anyways, please like the video. Thank you.